and today's lesson is on thermal energy, heat, and temperature.
So today let's consider thermal energy, heat, and temperature. So thermal energy we know to be the total vibrational kinetic energy of the particles in an object, and heat, we know that to be the transfer of thermal energy from one object to another. Temperature, that's the average vibrational kinetic energy of the particles in an object. So let's get the units here. The units of thermal energy and heat will both be joules, and temperature, of course, we'll have in degrees Celsius. So how much heat is required to change the temperature of some object by some amount? Well, if you think for just a second, you'd say, well, it should be proportional to the mass of the object. More massive objects need more heat to warm up. It should be proportional to the change in temperature. Of course, a greater change should require more heat. And finally, it should depend on the substance that the object is composed of. This makes sense. Some objects require more heat to warm up than others do, and that depends on what they're made of. I'd like to pause on that idea for a second. This characteristic of a substance is called its specific heat capacity. Yeah, specific heat capacity. Let me just get that written down here. Here we go. And specific means per unit mass. Okay, so this symbol is Cp, and we have joule per gram degrees Celsius. So some substances require very little heat to increase their temperature, while others seem to require a large quantity of heat. Now think of a natural seeming example. Consider just 1 gram of liquid water. Okay, we want to raise that up by 1 degree Celsius. And the amount of heat energy that we need to do this has got a name. It's actually a really nice unit. It's called a calorie, a small c calorie. Not the large c calorie that you're used to seeing for food, but a small c calorie. It seems useful actually, kind of human in scale. It's a little water, it's a little temperature, very relatable, but sadly not an SI metric unit. So in SI metric, we use joules for energy. And as it turns out, joules are quite a bit smaller than calories, about a quarter the size approximately. Let's look. Turns out 4.184 joules makes up 1 calorie. And that gives us the specific heat capacity of liquid water. Quite nicely, actually. Here's the first one, Cp, the heat capacity of liquid water is 4.184 joules per gram degrees Celsius. So you need this amount of energy to raise the temperature of 1 gram of liquid water by 1 degree Celsius. Let's see if we can put this all together now. Well, we'd like to get an expression for the heat flow. Well, the heat flow into an object, that'll be called Q, will be the mass of the object, M, the mass. Multiply that by the heat capacity of the object, Cp, and we'll multiply that by the change in temperature of the object, delta T. The units will be, let me see here, joules, grams, joule per gram degrees Celsius, and finally degrees Celsius at the end. This will be our equation for heat flow. It'll be positive when heat flows into an object and negative when heat flows out. Let's use this to calculate some useful information. And really, what could be more useful than a nice cup of tea? Anyway, I want to make some tea for a couple of students who are by after school to check up on some of our recent topics in chemistry. So let's see. We'll need to raise 600 mils of water from 8 Celsius to 93 Celsius. My question is, how much energy do you need? Well, here's a solution. We'll use our expression Q equal mc delta T from above. 600 mils of water at 1 gram per mil. That'll give us the mass. There's a heat capacity of water, and finally the temperature differential, mc delta T. Let's calculate that. We'll put the numbers in our calculator here. Just give me a second to press all the buttons. Make sure you use delta T at the end, and you get quite a large number of joules, 213,000 and some. This question is just 3 sig figs, and joules are kind of small, so we'll use kilojoules here. I'll call it 213 kilojoules. In another example, we'll add 629 joules of heat energy to 15 gram sample of liquid water that's currently at 20 degrees Celsius. What will the new temperature be? So the solution looks like Q equal mc delta T again, and we'll solve that one for delta T. So a bit of algebra gets it to you, and just get the values in here. There's the heat flow, the heat capacity, and the mass of our sample. Check the units, always check. And we just get our calculator and calculate this one. Make sure you multiply and divide properly, divide everything on the bottom, and you get 10.022 degrees Celsius, or 10 degrees Celsius to 3 suffix. But that's not the final temperature, that's delta T. Okay, remember we started at 20. So we'll just get the final temperature is the initial one plus a change, 30 degrees Celsius. Okay, so look, values for specific heat capacity, Cp, are found in tables and for various substances in different phases. So the heat capacity for liquid water, which we know 4.184 joules, is different from that for water ice, 2.108 joules it turns out. Also different from, say, solid iron at 0.444 joules. Notice how small that value is compared to water, and it means that to raise just 1 gram of solid iron by the same temperature as 1 gram of liquid water requires only about 10.5% the energy. So the way to interpret that is to think that iron is quite a lot easier to warm up than water. You don't need to put as much heat energy in to increase the temperature of iron. And this has various effects with different substances. Okay, changing phase, though, be careful, involves energy but not a change in temperature. And of course, our delta T is going to be 0, but there's still energy, so we can't use the same formula, and we'll get to it next time. Anyway, thanks everyone, and see you soon. Don't forget, have a look next to videos in the playlist for more, and stay tuned for our next lesson, lesson 8, heating and cooling curves.
This is my dad's YouTube channel. It's awesome. So like, comment, and subscribe.
Hi guys, it's me Bella, and today's lesson is redo.